Hello everybody, welcome back. I wanted to share a few comments about my experience with the Glidewell Fastmill.io so far. So we've been using it for about 4 months. It's been really impressive, to be honest. So as many of you know, I've been a Ceric user since 2007. Used the red cam, the blue cam, the omni cam, and then the prime scan. Prime mill, and the compact mill, and the MCXL and the MCX, and all that jazz. So I've had some opportunities to use a bunch of different Ceric devices. Milled zirconia, lithium disilicate, Emax. What else? Let's see. I milled a whole bunch of things. Some of the hybrids. What's it called? Lava Ultimate, GC Cerismart. There's a whole bunch of them. So I personally, down here on tube number 19, have a Lava Ultimate crown. And the crown itself has been in place for about, 10 years now? Maybe 11 years? And I know Lava Ultimate had their crown permissions removed by the FDA. It's no longer indicated for full coverage crown restorations. But I've had mine in place, like I said, for 10 years. I've intentionally tried to break it. Not sure if you can see it. Right here. Yeah, that's the one I did myself. I also did, attempted to, maybe I should say this, began my own root canal on. So that was an adventure too. Anyway, so let's talk a little bit about the Fastmill. So as far as the process goes, we use little ingots of fully sintered zirconia. And these are heavy. They're very heavy. For those of you that have used zirconia before, it's got they're heavy blocks. They're dense. The process is very simple. We scan with an iTero. We have the 5D with NIRI, which I really like that particular scanner. It's an open system, so you can scan it with anything. And we have our 5D, our iTero set up to inject the files directly into the Fast Design computer, which is in our little lab. And there's some videos here that you can watch as well when you get a minute. Then it takes maybe 5 minutes to design it. And I've noticed in the 4 months, the last 4 months as I've started using it, since I started using it, the margins, the AI that's built into the software finds the margins much more accurately now. It's as if it's learning from me. So I tend to prep modified chamfer, and I usually go slightly subgingival or equigingivally, depending on the location and, of course, where the caries is or a previous filling. So my margins, usually the enamel meets the gingival margin, or slightly subgingivally. And so if I don't pack cord, which I haven't done in a very long time, or use a laser to trough, which again I haven't done in a very long time, then it can be difficult for the naked eye, if you didn't prep it, to see where the margin is. Sometimes you can see the white band of enamel, and then there's the pink, but sometimes it's a little bit blurry. Anyway, I've noticed as we're inputting and adjusting the margins, which is really one of 2 steps we have to do as we're designing the crowns with the Glidewell Fastmill, the software is getting better. So we're having to do less and less input on the margins. So once the crown is marginated, and it's a very capable software. It's very simple, but it's very capable. Then the crown is designed, and there are several different options. We can copy the crown shape, the restorative site anatomy. For instance, if you are designing a crown underneath a partial, which I've done several times now with the Fastmill. And we can also use a copy, a mirror, a copy and mirror of an opposing tooth. So I have several little ingots here, little blocks that for whatever reason the machine stopped in the middle of. And oftentimes when it stops, and honestly, this is all of them. I have 5 of them here. 5 of them in 4 months. These are the only error blocks that we've had. And we're doing, 4 of these a day on average. Maybe 5, maybe 6, I don't know. It just depends. So it's interesting to note how the machine manufactures it. And let me go back to the process. So once we design, and once we marginate, then you get the proposal, and again, you can choose which design option you want. And then all it takes is to adjust the contact. So you're now marking where the interproximal contact is. So you do the mesial, you do the distal, then you hit fix contacts, and at that point the software goes through and adjusts everything so that it matches your contact size. And if you want to, you can adjust the contact point, the location, the size, the intensity. Just like with most other systems, there's an incredible amount of customization you can do to the proposal settings. But I find I leave my contact strength at 10 microns. 10 microns. Initially, it was set up at 30 or 40, and I found that took a long time to adjust. So I didn't end up leaving it at that. I lowered it down to 10. Sorry, my wife is asking me questions. So once you get it designed, after you hit fix contacts, essentially, assuming everything is in good order, and it very rarely requires much input, you just send it to the milling machine. The software opens up. It's a separate software, but on the same device. So there's a fast design software and a fast milling software. And you can connect the milling software to multiple devices if you have more than one mill. We only have one, although I'd be interested in considering buying a second. So once you get it milling, then it goes through, and much like many of you have seen, the milling machine will actually measure the block. So you insert the block. This particular block has only one way to insert it. You torque it down. There's a little torque wrench it comes with, and then it measures it. It confirms that it's the right size. And there's only one burr, as I mentioned before, one diamond burr. So after that, you can see sequentially, it'll go through, and it essentially cuts basically, I don't know, what's that, 3/4 of the block height. You can see here's another one that's a little bit farther along in the process. Let me put that down on my shirt so you can see it. So these, incidentally, we had burrs break, and it was because I or one of my assistants hadn't changed the coolant level, and so I think the burrs heated up and then broke. This one is a premolar that's in that process. You can see the cycle that it goes through. And then this is a molar that's almost done. You can see that. And now I haven't polished any of these. So as I'm holding them up, I haven't polished any of them. And this is a finalized, let's see if it'll focus, crown. So this is not polished. This is straight out of the milling machine. I did it because I'm crazy, but I've taken one of these and put it in my mouth and felt it with my tongue, and it feels perfectly smooth. You can, if you're wearing loops, you can see the milling pathway, the grooves that are in there, but you can't feel them. This is smooth. Your tongue can't perceive it from an aesthetic standpoint once you get the sprue off. So these you'll just take and break, and then take a fine diamond and finish the surface where the sprue came off of. But it leaves, what is that, 1.5 millimeters, maybe 2 millimeters of contact right there. And then we finish that off. There's no option to adjust the sprue location yet, but I'm told that that's a work in progress. So once everything is done, you break it off, you polish it, polish that surface. Really, you can just hit it with a fine or extra fine, a red or a yellow diamond. And then there's a small polishing kit that it comes with. It takes just a moment on a low-speed contra-angle. And then you bond it in place. So we treat the inside, and either micro-etch it with aluminum oxide or scrub it with isopropyl alcohol. Once that's done, we treat it with IvoClean, scrub out the inside. There are a number of different chemicals that you can use to prep it. And then use whatever bonding protocol you use, or lute it, with something like a conventional luting cement. Anyway, so I have had, I think I've had one crown debond in 4 months. It was a tooth number 18, and looking back, I believe it was because we didn't treat the inside either by micro-etching it or prepping it with IvoClean. It was bonded by one of my assistants. I have had 0 crowns, none of them, break or fracture. I tend to prep with an 856016 burr, so I know my reduction is about 1.5 to 2 millimeters. and I design these with a 300 or 400 micron offset. But it almost always requires a little bit of adjusting because all teeth will settle just a smidge after you prep them, so there'll be a little bit of fine tuning. Anyway, in general, when you compare to the CEREC, the Omnicam, MCXL, PrimeScan, PrimeMill, I really have enjoyed the Glidewell Fastmill IO. I don't have a furnace. There's no need for a furnace anymore. Now, certainly if you're the kind of doc or whatever that would like to get into staining and glazing, go for it. I feel like I don't need to. If there's a big cosmetic case, I'm going to send that to the lab anyway. I don't know that I'm going to get into a whole bunch of anterior aesthetics just because of the time consumption that it takes in the lab. We have done single centrals, single laterals with Bruxer aesthetic now, which is a little more translucent, slightly lower flexural strength, but a little more translucent than the Bruxer now. The now stands for no oven weight. Anyway, I've been very, very pleased with the Glidewell Fastmill, and it saved us thousands of dollars. I have patients that ask me, well, how much does that machine cost? And you can throw out a ballpark number, whatever you're comfortable saying, whatever you're comfortable paying for it. But ultimately, for me, in my estimation, the cost of me manufacturing a crown in office is actually more expensive than it is for me to send this crown to the lab. Let me say that again so you don't think I made a mistake. The cost is more expensive to mill it in the office than it is to send it to a lab. I could actually get labs to manufacture a zirconia crown for $69, depending on where you go. And some of those are overseas, some of those are local. You can get Emax crowns for pretty darn cheap too. So I'm actually paying more than that for each of these crowns when you count the time, the cost of the machine, and the blocks, of course. So yes, these crowns are more expensive than a lab crown in most cases. However, and I tell the patients this is not a secret, when I send this crown to the lab and put a temporary on, you now have to come back. And so there's a second appointment there that I have to reserve for you that I could have reserved for another patient. So in the end, honestly, the total savings is greater. So yes, they're more expensive to make in office, but in the end, they're better for the patient. And they're better for the office because we can now save that appointment that we had made, that we would have made for a permanent crown delivery after a temporary crown. We can now give that to another patient, which in turn allows two benefits. Number one, the patient who came in for the crown gets their crown in one day, doesn't have to wear a temporary. There are a lot less post-op sensitivity issues and problems and temp crowns debonding. And number two, it frees that appointment slot up for another patient, which in turn creates an additional revenue for us, which could potentially turn into another one of these guys, same-day crown, which, as we all know, in general dentistry, bread and butter dentistry, most of what we do is crowns and fillings and root canals and all that jazz. Anyway, hopefully this has been helpful, just kind of as a recap, to go from one of these guys to one of these guys with the Glidewell Fastmill.io. Takes about 40 minutes for it to mill, sometimes a little bit longer, sometimes about 50. I would encourage you not to try to mill bridges same day unless you're doing it temporary. It takes a long time. But in the end, the time savings is worth it for a single unit crown to have a patient in one day get their crown. And the material, I've been very pleased, very happy with the material, the quality of the material, the strength, the durability. Again, I've had no issues or concerns with any of these restorations. Breaking, had one debond in 4 months, primarily because I think it was user error. We've made them underneath partials. I've made them opposing each other. Root canals and crowns at the same time. Very, very, very positive experience. So hopefully that's been helpful. I will see you guys in the next video.